All right, hi guys. Let's start section two. Forces and pressure in fluids. So, transmitting pressure in a fluid. So, a fluid exerts. Remember, a fluid is anything that's liquid or air, basically. A fluid exerts pressure equally in all directions at a given length. So, again, this means like if you're in a lake, a bathtub, a pool, whatever. If you're like the same depth in every one of those cases, a pool, a lake, an ocean, or whatever, the pressure is exerted equally at all depths. Okay, I mean at that given depth. Sorry, the amount of pressure exerted by a fluid depends on the type of fluid and its depth. Um, so Pascal's principle. So according to Pascal's principle, change in pressure at any given point in a fluid is transmitted equally and unchanged in all directions throughout the toothpaste. So please memorize that. Okay, so for example, I'm going to say that again actually. According to Pascal's principle, a change in pressure at any given point in a fluid is transmitted equally and unchanged in all directions through the fluid. So what this means, if you have a toothpaste tube, if you squeeze it at the bottom, it's being transmitted equally and unchanged throughout the fluid. Okay? If you are squeezing a balloon at the very bottom, it's going to be equally and unchanged throughout the thing. If you're squeezing it in the middle, if you're squeezing it at the top, okay? There's even a picture in the book, I can't remember what page, but it's a 2 liter bottle and they're squeezing it in the middle and it'll show you where it's all being squeezed. Okay? Um, so, hydraulic fluids. Hydraulic system is like the chairs, like my chair that goes up and down behind my desk. That's a hydraulic system. Um, Anything has pistons. So, like when you ever seen a dump truck uh, empty out the dirt, those are pistons on the side that's pulling it up and stuff. When one of those big trucks that's getting like a dumpster or it's emptying out a big trash can, like those ones at our school, it's lifting it up by pistons. If you go to like the car repair place and they lift your car up, those are pistons that are doing that. Okay, so that's a hydraulic system. A hydraulic system is a device that uses pressurized fluid acting on pistons in different sizes to change force. Okay, so a device that uses pressurized fluid acting on pistons of different sizes to change a force. So, an input force is applied to the small piston, which pushes against the fluid sealed in the hydraulic system. Applying Pascal's principle, you know that the pressure is transmitted or produced in a small piston um, is transmitted throughout the fluid in a large piston, equally and unchanged. Okay, this is way easier if I draw this at school, but I can't. So I think there's a picture down here. All right, so in a hydraulic lift, you have a big piston and you have a little piston. Okay, and because of the different sizes, it can actually lift up a big dumpster or whatever. Okay, so in a hydraulic lift, an increased output force is produced because a constant fluid pressure is exerted on a larger area of the output piston. So, okay, yeah, good. Okay. I think we went through this earlier when we did chapter 3. I can't remember though. Sometimes I put it in there and sometimes I don't. Okay, so this is like at the oil change place. Well, they don't lift that up anymore, a car repair place. So here's a piston. Piston is the small one, and this is the large one. Okay. So usually there's some kind of button that you push or something that starts the compressor. Okay. And so what it does is this pressure is exerted on fluid in a small cylinder, usually by a compressor. Okay. So I like to think of this as like a hose. When you are using your hose and you're just letting it flow, it's not very strong. But if you put your thumb over some of it, doesn't the water come out stronger? This is kind of the same theory. Okay, so there's like a compressor and you push the button and it goes, and so it pushes down and goes, and it pushes it all the way through, and then when it gets here it goes, and it pushes up something big. It's kind of like a toothpaste tube that's kind of clogged. My son leaves the cap off all the time, and it's always clogged. So you have to squeeze really hard, and then when it gets unclogged, the toothpaste goes whoosh right across the mirror and everywhere else and waste it all. That's what this is kind of like. Okay, so pressure is exerted equally and in all parts of the enclosed static fluid. Static fluid means fluid that's not moving. Okay, so because it's small here, it's with you're doing so much force, and then when it gets here, it's like whoosh. Okay, so the force in the small cylinder must be exerted over a much larger distance from here to here. A small force exerted over a large distance is traded for a large force over a small distance. Okay? Though the pressure is the same, because remember Pascal said it's equally and unchanged throughout, it is exerted over a much larger area given the multiplication of force that lifts the car. So what is able to lift this big car is that this is so small right here, and this is so big. Okay. So the amount, the input force is increased depends on the areas of the piston. Area of the piston is here and here. Okay? So the amount of input force is increased so much depends on this. So I only have to put, like if this was my chair at work, okay, I only have to push the thing up and then it can basically lift me up. Okay? So because of the difference. Okay? And this is like, again, you're squeezing your toothpaste tube through this little small hole that's because it's clogged, and then all of a sudden it opens up and it shoots up really fast. That's the same kind of thing. So if the large piston has 8 times the area of the small piston, the output force is 8 times greater than the input force. Input force is going to be what you input, so it's here. I'm pushing in the button usually, or start the compressor or whatever, and then the output force is this going up. Okay? So this would, let's say that this is 8 times bigger than this. It means that it has 8 times more output force. Or it increases it is a great times, but it also makes this 8 times bigger. The input force makes it 8 times, because it's small, the input force is 8 times greater than the input force. Okay? So this is the formula we're going to use. Hydraulic lifts use the following formula. Pressure 1 equals pressure 2, because remember Pascal's principle says that the fluid is exerted equally and unchanged throughout the entire hydraulic machine. So it actually P1 and P2 are the same, but what's different is the areas and the force. Okay, so here's the problem here. F1, which is force over area, equals, and this is F1 over A1 equals F2 over A2. So, and F over A is pressure, so that's 1, and then F over A is pressure 2, okay? So, if there's anything that talks about all the math problems, two pistons, you're going to use this formula here, okay? So you just got to make sure that this is the input force, this is the input area, output force, output area. Okay? All right.